Singapore Math helped teachers understand their role as a teacher. It helped them improve their content knowledge. By looking at the textbooks, they understand the mathematics they teach, they understand the methods they should use to teach.
Fractions are a subset of a larger group of numbers called rational numbers. Rational numbers exist in many forms, such as decimals, percent, and ratios. What makes a number rational? A rational number is any number that assumes a form a over b such that b is not equal to 0. Is 1 over 2 a rational number? The answer is yes, because it assumes a form of a over b. Is square root of 2 a rational number? The answer is no. It is not a rational number simply because you cannot write it in the form of a over b. The goal of this video is to share some of the best practices on how to teach addition and subtraction of fractions. This video will focus on addition and subtraction of like fractions, as well as fractions with different denominators. Fraction algorithms pertain to fundamental operations involving fractions. These operations include addition, subtraction, multiplication, and division of fractions. In teaching addition and subtraction of fractions with like denominators, we can use manipulatives. For this video presentation, we will be using number sticks. These are examples of number sticks. Orange sticks for 10, blue sticks for 9, brown sticks for 8, black sticks for 7, green sticks for 6, yellow sticks for 5, pink sticks for 4, gray sticks for 3, red for 2, and white for 1. We are going to represent fractions using these number sticks. Suppose we are going to add 1 over 6 and 2 over 6. We start by modeling the fractions using number sticks. This green rod represents 6, and this white one represents 1. So this represents 1 over 6. In the same manner, we represent 2 over 6 using number sticks. So we are using 2 white squares to represent 2 parts. When we say 1 over 6 plus 2 over 6, it is similar to 1 part plus 2 parts. Together, 1 part plus 2 parts is 3 parts. So 1 over 6 plus 2 over 6 is equal to 3 over 6. Let's have another example. 1 over 5 plus 2 over 5. So this is 1 over 5 plus 2 over 5. 1 part plus 2 parts equals 3 parts. So 1 over 5 plus 2 over 5 is equal to 3 over 5. The use of number sticks and other forms of manipulatives is grounded in the theory of CPA: concrete, pictorial, and abstract. we begin teaching the concrete concept using concrete objects. And then, we will be using illustrations to strengthen the skills. For example, 2 over 4 plus 1 over 4. We start using manipulatives. We represent our fractions using number sticks. From this illustration, 2 over 4 plus 1 over 4 is 3 over 4. Using the pictorial stage of CPA, we can use illustrations. We create a rectangle and divide it into 4 parts. We shade 2 of the 4 parts to reflect 2 over 4. We do the same for our next fraction, so 2 shaded parts plus 1 shaded part is equal to 3 shaded parts. So 2 over 4 plus 1 over 4 is equal to 3 over 4. The numbers sentence is now the abstract component of CPA. Here we add fractions using concrete, pictorial, and abstract of the Singapore mathematics pedagogy. We move on to subtraction of similar fractions. 4 over 5 minus 1 over 5. Recall that the idea of subtraction is taking away parts. We are going to use the same idea in subtracting fractions. Let's begin with concrete representation or modeling. We model 4 over 5 using our number sticks. We are going to take away one part. We take away one part from 4 over 5. The result now is 3 over 5. Say we have here 5 over 7 minus 2 over 7. So we model first 5 over 7. We take away 2 parts. What is left now is 3 parts. So 5 over 7 minus 2 over 7 is 3 over 7. After doing this series of examples, we can engage the students in making generalizations. This time, we are going to learn how to add fractions with different denominators using our number sticks. For example, you have here 1 over 2 plus 1 over 3. First, we shall focus on the denominators 2 and 3. 2 and 3 are different numbers. Hence, 1 over 2 plus 1 over 3 are dissimilar fractions. To add dissimilar fractions, we must first get the least common denominator, or LCD. So we are going to represent 2 and 3 with number sticks. Arrange them one on top of the other. And then, we are going to add sticks of 2 and 3 until both are equal. With the aid of concrete materials like number sticks, we are lessening the abstractness of numbers. Let's get the green bar, which represents 6. This green bar is our least common denominator, or our LCD. We're almost there. Now, we need to figure out the numerator. We go back to our blocks. How many sets of 2 are there? We have 3 sets of 2's. So 3 times 1 is 3. How many sets of gray bars are here? 2 times 1 is 2. Lastly, we add the numerators. 3 plus 2 is 5. 5 over 6. Let's have another example. Let's have related but unlike denominators. Say 1 over 5 plus 2 over 10. So we are going to focus our attention first on the denominators 5 and 10. Let's try to make both bars equal in length. Let's add one more 5. Can you see now what is our denominator? Very good! So the LCD is 10. Then, how many bars of 5 are there? Correct, it's 2. So 2 times 1 is 2. 1 bar of 10 times 2 is 2. So 2 plus 2 is 4. We can further reduce the answer into its lowest form, which is 2 over 5. This time, let's do subtraction of dissimilar fractions. 3 over 5 minus 1 over 3. We will identify the least common denominator first before performing the operation. Put them one on top of the other and make both bars equal in length by adding same colored bars. When yellow and gray bars are equal in length, we count to determine our LCD. Orange is 10, yellow is 5. So we have 15 for our LCD. How many yellow bars are here? 3. 3 times 3 is 9. How many gray bars are here? 5. 5 times 1 is 5. Then we do our subtraction. 9 minus 5 is 4. 4 over 15. Let's have another example. Let's say we have 3 over 4 minus 1 over 2. Our LCD is 4. 1 block of 4 times 3 is 3. 2 blocks of 2 times 1 is 2. So 3 minus 2 is 1. 1 over 4. The use of manipulatives such as number sticks in order to perform fraction algorithms and any other mathematical operations is rooted in the principle of concrete, pictorial, and abstract, or CPA. With the aid of concrete materials like number sticks, we are lessening the abstractness of numbers and slowly building the conceptual understanding of the pupils. We hope that this video was able to clearly share with you how to teach addition and subtraction of fractions to your students using concrete, pictorial, and abstract of the Singapore Mathematics Pedagogy. Stay tuned for our next tutorial on multiplication and division of fractions. Thank you for watching.